Okay, in this video our main focus is going to be this second bullet point, finding reference angles. Reference angles, the values of the trig functions of angles greater than 90 degrees or less than 0 can be determined from their values at corresponding acute angles called reference angles. And the definition here says, let theta be an angle in standard position. Its reference angle is the acute angle theta prime, formed by the terminal side of the angle and the horizontal axis. And then down here they do give descriptions for finding these reference angles in quadrants 2, 3, and 4. You know, we see down here theta prime is the reference angle we're looking for, and in each quadrant it's a slightly different way to find this reference angle. I think an easier way to look at this is just thinking, if you're given an angle, the reference angle is the quickest way back to the x-axis. Here in the first picture we open our angle up and we end here, our terminal side is in quadrant 2. The quickest way back to the x-axis, sort of think about it as like rounding a decimal. We want to get back to the x-axis as quick as possible. The quickest way to do that is to just measure this angle here. And that's what we have underneath in the description. Pi minus the angle, or 180 minus the angle if we're in degree mode. That's just the quickest way to get here to the 180 degree angle, or back to the x-axis. In the middle picture, we've opened our angle up and we're past the x-axis. We're down here in quadrant 3. And we want to just think about this again as the quickest way back to the x-axis. If we're anywhere in quadrant 3, the quickest way back to the x-axis is to round it up to the x-axis. So we would just measure this angle here. And to measure that angle, it would be the angle, the big angle opened up more or past the x-axis. So we would subtract pi or subtract 180 degrees to get back to the x-axis. And in the final picture we've gone all the way around and we're somewhere in quadrant 4. As long as we're anywhere in quadrant 4, the quickest way back to the x-axis is to just round it up here to the positive x-axis. So we just want to find the measure of that angle. The measure of this angle is our reference angle. And again, below the picture we have our 2 pi minus the angle, or 360 minus the given angle if it's given in degrees. Just think about it as the quickest way back to the x-axis. And here in example 4, we're going to find some of these reference angles. So let's see, part A, theta is 300 degrees. So first let's do a little sketch of it. If we start here on our initial side, we'd have a 90 degree angle, 180, 270. The full circle would be 360, so that would be a little far. So we know we're somewhere here in the 4th quadrant. So our reference angle is the shortest route back to the x-axis, and anywhere in the 4th quadrant, that'll take us back to the positive x-axis. Well, a full lap is 360. We've used up 300 degrees opening our angle, so the difference between there is 60. So for part A here, our reference angle theta prime would be equal to 60 degrees. In part B, now we are in radian mode. You know, the giveaway here in part A, we had a degree sign. Here there is no degree sign, and that means we're in radian mode, even though, you know, most of the time we're used to seeing a pi in there too. So let's see, when we talk about the coordinate axes in terms of pi, we know our positive x-axis is a half pi, or a positive y-axis is 1/2 pi, 1 pi, 3/2 pi. And we should know that pi is roughly 3.14. And this measure is in radian mode 2.3. Well, half pi, let's see, pi divided by 2 is about 1.57. So this would be roughly 1.57, and our angle is 2.3. So we're somewhere in between those values, and that tells us for sure we are somewhere in the 2nd quadrant. And our reference angle, the shortest route back to the x-axis, would be this angle here. See, if we opened up 180 degrees, or pi radians, would get back to the x-axis. So we want to do pi radians minus the angle that we have here to find our reference angle. So we want to find pi minus 2.3. And since pi is irrational, subtracting from that will also give us an irrational answer. So pi minus 2.3. And we're left with 0.8416 radians. 0.8416. So there's our reference angle for part B in radians. Part C, we're back to degree mode, but now we have a negative angle, negative 135 degrees. So if we start at the positive x-axis, this would be negative 90, negative 180 would be too far, so we're somewhere in the third quadrant. And the reference angle, the shortest route back to the x-axis, would be this angle right here. Well, half of a circle is 180. We've used 135 degrees here. So 180 minus 135. 45 degrees. Our reference angle here would be 45 degrees. So it says here, to see how these reference angles can be used to evaluate a trig function, consider the point x comma y on the terminal sine of theta as shown in the figure. So here's our point xy in the second quadrant. By definition, you know that sine is y over r, the y coordinate over that hypotenuse r. And tangent is y divided by x, just the y coordinate divided by the x coordinate. For the right triangle with the acute angle theta prime, this reference angle, and the side lengths are absolute value of x and absolute value of y. If we go to the picture, from point xy we drop this perpendicular down, so we have created a right triangle. From our reference angle theta prime, we have an adjacent side and an opposite side. So if we look at the sine of theta prime, our reference angle, we know that that is the opposite side over the hypotenuse. The opposite side happens to be the height of this, which is our y coordinate. And the hypotenuse is r. And the tangent of our reference angle, theta prime, down here tangent is opposite over adjacent. Well, the opposite side is the height, or the y side, and the adjacent side is the x value. And again, we're thinking with a triangle here, these are absolute values. So now if we compare the sine of theta and the sine of theta prime, it's y over r compared to the absolute value of y over r. And tangent is y over x. For our reference angle, it's the absolute value of y over the absolute value of x. So what does this mean? Well, it follows that the sine of the angle and the sine of the reference angle are exactly the same, except maybe the signs are different. One's positive, one's negative. The same is true for tangent of the angle and the tangent of the reference angle. And for all the other trig functions. In all cases, the sine of the function value can be determined just by what quadrant theta lies in. And it says here to find the value of the trig function of any angle. First, determine the function value of the associated reference angle, theta prime, and depending on the quadrant, affix the appropriate sign to the function value. Now that's how the book shows it here. This might make a little more sense to some people. If I have my xy axis, and let's just say our angle wound up over here in the second quadrant. So here is our angle, theta. And let's say that theta is 150 degrees. So the reference angle, that's easy enough to find, the shortest path back here to the x-axis, would be 30 degrees. So here we have a 30-degree angle that goes up and hits this point, and this would be negative x comma y. What the reference angle does is, it's sort of like we're reflecting this back to the first quadrant. So let's do this. If I come up here in the first quadrant, and I'm going to make a 30-degree angle here. So our reference angle was 30 degrees. Over here in the first quadrant, you know that 30-degree angle will have a similar point. You know, as I reflect this angle around, so I reflect this point around, and here it was a negative x value. Well, now that we're back in the first quadrant, it's going to be that same value but positive. This is going to be the positive reflection of this negative x. And the y value is just the height here. We have that similar height here. So this point in the first quadrant would be xy. Negative xy in the second quadrant, positive xy in the first quadrant. So the sine of this 30-degree angle and the sine of this 30-degree angle are only different by a sign. Over here it's negative, over here it's positive. And that's how we're using these reference angles. So by using these reference angles and the special angles discussed in the preceding section, you can greatly extend the scope of the exact trig values. For instance, knowing the function values of 30 degrees means that you know the function values of all angles for which 30 degrees is a reference angle. For convenience, the table below shows the exact values of sine, cosine, tangent functions of the special angles and the quadrant angles. So here are the angles in degrees, our special ones 0, 30, 45, 60, 90, and then the quadrant angles 180 and 270. And in radians, we have our radian angles, pi over 6, quarter pi, third pi, half pi, pi radians that goes with 180, and 3 halves that goes with 270. So here are sine values. Sine values start small at 0, and then we move up 1 over 2, the square root of 2 over 2, the square root of 3 over 2, 1, 0, negative 1. And then the cosine values, 1, and then we sort of count down here, the square root of 3 over 2, square root of 2 over 2, 1 half, 0, negative 1, 0. And the tangent values are just sine divided by cosine. 0 divided by 1 is 0. A half divided by root 3 over 2 is root 3 over 3. Root 2 over 2 divided by the root 2 over 2 is 1. These two fractions divided are square root 3. Here we have 1 divided by 0. We can't divide by 0, that's undefined. 0 divided by negative 1 is 0. And another divide by 0 scenario, another undefined value. And down here in this blue box we do have a nice study tip, and this is how I remember doing this to remember these quadrant angles. Oops. So it says learning the table of values at the right is worth the effort, because doing so is going to increase your efficiency and your confidence. It really pays off, especially in calculus and calculus 2. Here's a pattern for the sine function that may help you remember the values. We just got to remember our special angles, 30, or 0, 30, 45, 60, 90. And for the sine values, we start small. Sine starts small. So our denominators are always 2. Our numerators, square root of 0, square root of 1, square root of 2, square root of 3, square root of 4. Well, the square root of 0 is 0, and divided by 2 is 0. Here, the square root of 1 is a perfect square. Square root of 1 is 1, so that's our 1 half. And then we have our root 2 over 2, root 3 over 2. For the 90 degree, the quadrant angle, the square root of 4 is 2. So we have 2 divided by 2, or 1. So if we remember that little pattern, denominators are 2, our numerators start small for sine and increase 0, 1, 2, 3, and 4 under the square root sign. To get cosine, just reverse it. If we wanted to do the cosine of that same angle, for these same angles at the top, we would start with the square root of 4 over 2 and then count down. Square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, or 1 half, and then square root of 0 over 2, or 0. Example 5, it says evaluate the trig function. And let's see, that little sketch will really help out. Here are our axes, and in part A we have radian measure. It wants the cosine of 4/3 pi. So if we do a quick sketch here, 4/3, that's 1 1/3 pi as a mixed number. So if I start sketching my angle, this would be 1 pi and 1 1/3. A third's less than a half, so I'm going to be somewhere here in quadrant number 3. This is 1 1/3 pi. Well, my reference angle, what's the quickest way back to the x-axis? Well, I got to go back right up here to pi radians. Well, the difference between pi and 1 1/3 pi is the third pi. So my reference angle is a third pi. And that's just telling me that the cosine of 4/3 pi is going to be the same as the cosine of a third pi, except the sign might be different. Well, first let's figure out what the cosine of pi over 3 is. Well, cosine here, pi over 3, we know that's a half. So we know this is equal to 1/2. Is that positive or negative, though? We are down here in quadrant number 3. X's are negative, Y's are negative, sine and cosine are both negative. In the third quadrant, tangent is positive. So we know that this is a negative value. Our reference angle told us the 1/2. Our placement in the 4 quadrants told us that that was negative. Part B, we are in degree mode, and it is a negative angle. So let's see here, would be negative 90, negative 180, negative 270. We've gone too far. So we're going to be somewhere here in the second quadrant, negative 210 degrees. And, we opened her up this way. And remember, these reference angles are just the quickest way back to the x-axis, and we're always going to measure them positive. So we want to get back to here. Well, we know this is 180 degrees, and that's 210, so the difference between there is 30. We have a 30-degree reference angle. The tan of our negative 210 degrees is pretty much the same as the tangent of 30 degrees, except the sine's going to be different. So the tangent of 30 degrees, tangent 30 degrees, root 3 over 3. So what we're looking for, this tangent of negative 210, is root 3 over 3. But is it positive or negative? Well, in the second quadrant, we have negative x values, positive y values. Again, our y values are equivalent to sine. So here, sine is positive, cosine is negative, tangent is sine divided by cosine. Positive divided by negative is negative. Negative square root of 3 over 3. Our last one, letter C, cosecant of 11/4 pi. So we're back in radian, and we're finding a trig function that's not on our, our chart. We're used to sine and cosine and tangent. But a reciprocal identity will save the day. So here, cosecant of 11/4. Well, let's switch 11/4 to radian, or a mixed number. 4 goes into 11 2 times without going over, and the remainder is 3/4 pi. There we go. And I always double check here. 2 times 4 is 8, plus 3 is 11, 11/4 pi, same thing. So we want to sketch 2 3/4 pi. Well, a full lap is 2 pi. And then if we go back to the x-axis, that would be 3. So we want to go just a little bit under that. We went 2 pi, this would be 2.5. 2 3/4 takes us somewhere here in the second quadrant. So here's our angle. We need the reference angle, and this is 2 3/4. The reference angle, quickest way back to the x-axis. If this is 3/4 to get to 1 here, we know we have a 1/4 pi radian angle here. So this cosecant of 11/4 pi radians is the same thing as the cosecant of pi over 4 radians. So the cosecant of our given angle, 11/4 pi, is exactly the same, except maybe in sine, as the cosecant of pi over 4. Cosecant is the reciprocal of sine, so we can find this as 1 over the sine of a 1/4 pi radians. So sine of a 1/4 pi, sine 1/4 pi, root 2 over 2. So we're going to be 1 over the root 2 over 2. And of course we want to bring that up, flip it over, use our inverse functions. That's going to be the same thing as 2 over the square root of 2. And of course we'd want to rationalize. Multiply by root 2 over root 2, and we'll get 2 square roots of 2 over 4. And we will have that those leading coefficients reduced down. 2 over 4 will have the root of 2 over 2. Or excuse me, 2 square roots of 2 over 2. Your square root of 2 times the square root of 2 is 2. And then those will just cancel off. So our value is the square root of 2. We just have to figure out, is that positive or negative? Is cosecant positive or negative in the second quadrant? Well, cosecant is just the inverse of sine. In the second quadrant, sine is positive because y values are positive. So that means its reciprocal cosecant will also be positive. So the value of the cosecant of 11 fourths pi is positive square root of 2. In example 6, they're asking us to use some trig identities. And it says let theta be an angle in quadrant 2 such that the sine of the angle is 1/3. Find first the cosine of the angle and the tangent of the angle with the trig identities. So we have sine, we're looking for cosine. What we have that ties those together is the Pythagorean. Sine squared plus cosine squared equals 1. Well, we know sine is a third. 1/3 squared is 1/9 plus cosine squared of theta is equal to 1. And now to get this 1/9 out of here, I'll subtract it from both sides. Over here I'll have 1 minus 1/9, and this has been subtracted away. So our cosine squared of theta is equal to 1 minus 1/9. Well, this 1 we could replace as a 9/9. So we got 9 minus 1 is 8 over the denominator 9. And we have cosine squared. We want cosine, so we will root both sides, and I'll do numerator, denominator separately. So the square and the square root cancel, and we will have the cosine of theta equals, up top, square root of 8. You know, that breaks down into, 8 breaks down into 4 times 2. So the square root of 4 times the square root of 2. And the square root of 4 is perfect. That'll be a 2 times the square root of 2 for our numerator. Our denominator is a perfect square. Square root of 9 is 3. So there's our value, 2 root 2 over 3. Now it says we are in quadrant 2. Cosine has the same sign as our x values. So here I'll draw a quick little xy axis, and we're in quadrant 2. If I'm in quadrant 2, again, cosine is paired up with our x coordinate. Well, if I'm in quadrant 2, I'm on the x-axis here, and that is negative territory. So because we know that, this has to be a negative 2 root 2 over 2 square roots of 2 over 3. And in part B, they ask us to find the tan of theta. Well, tangent of theta is equal to sine of that same angle divided by cosine of that angle. And we were given sine in the setup to the problem, and we just found cosine. So here, tangent is going to be, sine is 1/3. And then cosine we just found here, negative 2 square roots of 2 over 3. And we have a fraction divided by a fraction, so I'm going to invert and multiply by the reciprocal. So we're going to have 1/3 times, now it's 3 over 2 root 2, and that's negative. On the diagonal, I see I got 3's, those will divide out to 1's. So now I have 1 times negative 1, or negative 1 in the numerator. My denominator, 1 times 2 square roots of 2 is 2 square roots of 2. And we have a radical down there, so we want to rationalize and get rid of it. And we'll just multiply by the radical itself. So, negative 1 times the square root of 2 is negative root of 2. And in this denominator, the square root of 2 times the square root of 2 is 2, times the 2 we already have. 2 times 2 is 4. So there we have negative square root of 2 over 4. Now in example 7, they're talking about using a calculator. Use a calculator to evaluate these trig functions. So the first one here we have is cotan of 410 degrees. Cotangent, though, is not a button on our calculator. We have sine, cosine, and tangent, but we do know we have the reciprocal identities. So here for part A, cotan is the reciprocal of tan. So if I find the tangent of that 410 degree angle, and then invert it by using the 1 over x key, I'll have the value of cotan 410. So I want to do tangent of 410 first, 410 degrees, and then find the tangent of that, tan, and I want to invert to get the cotan. So hit the 1 over x key. So this value for part A, the cotan of 410 is, and we usually round off to 4 decimal places, 8391 rounded up, 8391. 8391. Part B, sine of -7. In the first one, we were in degree mode. Now we're in radian mode. Even though there's not a pi there, you know, that can still be radian mode. Without that degree sign, we know we're in radian. So on this calculator, I hit radian mode, and I want sine of -7. So I'm going to do 7 and make it negative, and I want to take the sign of that. We do have the sign key. Boom. So -6570 when we round. -6570. So part B, -0.6570. And in the last one, we are still in radian mode, but now we got a pi in there, and we're finding secant. Secant is not a button on the calculator, but secant of some angle, a 9th pi, is the same thing as 1 over the cosine of that same angle, pi divided by 9. So calculators here. We're going to do pi divided by 9 is the fraction, and then we're going to do the cosine of that. So we'll clear here, and we have pi divided by 9 equals, so there is our fraction, and we're going to do the cosine of that fraction or decimal. So we just want to do cosine, and since this is an inverse, you know, we want to invert that to get secant. So we hit the 1 over x key. Boom. There we go. 1.0642. 0642. 1.0642. That's our secant of pi over 9. So it's time for some practice problems. Here we got for the huddle. Find the reference angle, theta prime, and sketch it. And next we evaluate sine, cosine, and tangent for the angle without using a calculator. So sketch it, find the reference angle, and then go to the table and figure out the sine, cosine, and tangent values from there. And in number 65, find the indicated trig values for the specified quadrant. So they're giving you a setup sign here, what quadrant, and they want you to find the cosine of that same angle. So give those huddle problems a try. You know, pause the video, try them out, turn it back on, and check out the solutions. So let's see here in the first problem, we just have to sketch it. So if I do a quick XY axis, and it says our angle theta is 160 degrees. So we start to open our angle here is 90. If we go back to the x-axis, 180, we've gone too far. So our angle is going to be up here, 160. And the reference angle is the quickest way back to the x-axis, and that would just be to jump down here to 180. Well, the distance between those, 180 and 160, is 20 degrees. So our theta prime is equal to 20 degrees. Oops. In the next problem here, it says evaluate the sine, cosine, and tangent without using a calculator. So first we're going to find our reference angle. 225 degrees, we have 90, 180, 270 would be too far, so we're definitely somewhere in the third quadrant. That's 225. And the shortest way back to the x-axis would be to go right up here to 180. Well, the distance between 225 and 180 is 45 degrees. So our reference angle is 45 degrees. So we want to find, let's see here, sine and cosine and tangent of that angle. And for a 45-degree angle in our first quadrant, you know, that's the one that sticks right up in the middle. Sine and cosine both have the value of the square root of 2 over 2. Square root of 2 over 2, root 2 over 2. Tangent is sine divided by cosine. And this value divided by this value, they're exactly the same. Anything divided by itself is 1. So there's our values. Now we just got to figure out the signs. Well, in the first quadrant, everything's positive. In the second quadrant, our y values are positive, so sine is positive, cosine is negative, tan is negative. Down into the third quadrant, sine and cosine are both negative. So we can definitely say sine and cosine are both going to be negative. And then think tangent. the value was a number divided by itself was 1. Negative divided by negative is positive. So there's our three values for sine, cosine, and tangent of that angle without using a calculator. In the last one, find the indicated trig values in the specified quadrant. So it says we know that we are in quadrant 4. So we're down here somewhere. Oops. And we also know that sine is y over r. Sine of an angle is y over r. And let's see here for our problem, it's negative 3/5. Negative 3/5. So we know we just got to figure out where does this negative sign go. Does it go with y or r? Well, remember, r is sort of the hypotenuse of the triangle, and we find that by x squared plus y squared under a square root sign. R is never negative. So we can automatically say, well, that 3 goes to the y value. And that makes sense if we are down here in quadrant 4. In quadrant 4, x values are positive and the y values are negative. So that's going to help us figure out, we have y, we have r, now we just got to find x. And let's go back to our formula. R equals the square root of x squared plus y squared. Well, if we plug in for y, negative 3, right here, negative 3 squared is 9. We know r squared, or r, is 5. I'll put that on this side. And the rest of it we don't know. So to solve this equation for x, I want to get rid of that square root sign. And to get rid of roots, we square it. And if we square the left or the right side, we got to square the left. So here on the right, if I square and square root, they cancel out. We're going to have x squared plus 9. X squared plus 9 is equal to 5 squared is 25. To solve for x, subtract 9 from each side. So we're going to have x squared equals 25 minus 9 is 16. And if we take the square root of both sides, we get x is equal to positive or negative 4. Positive or negative 4. But which is it? Is our x value in quadrant 4 positive or negative? Well, again, in quadrant 4, we are at underneath the positive x-axis. So that's going to be our positive 4. So we know that x is 4, y is negative 3, r is 5, from our initial setup and what we just found over here. And they're asking us to find cosine. Cosine of that angle theta, remember cosine is x over r. X we just found to be 4, r is 5. Cosine is 4/5. Here's the assignment for tonight.